Hi everybody, I am here to help you do your Mind Your Mutations activity for today. In case you're not quite understanding what you're supposed to do, keep watching and hopefully I can explain it for you. So what we're going to be doing in this Mind Your Mutations activity is very similar to what we did last week with the protein sentences activity, in that I have given you a handful of DNA strands. You're going to need to transcribe them into mRNA. But this time, instead of trying to figure out which codons are represented by which words, which will then come together to create a sentence, this time, when you come up with your mRNA codons, you're going to need to use the genetic code chart in your books, which is on page 367. Let's see, it's backwards from the camera, the yellow one there. You're going to want to look up that one to help you figure out which amino acids are represented by the codons. If you don't have your book for some reason, you can Google genetic code chart and a ton will come up for you. So if you have not yet, you might want to open up the Mind Your Mutations worksheet in the Google Classroom. You can pause me if you need to do that. Then once you have your sheet, you will see that at the top of that sheet is this particular DNA sequence. This is going to be our original DNA sequence or our normal DNA sequence for this particular activity. And so what I'd like you to do with the first normal, regular, original DNA sequence is to first transcribe it into RNA, mRNA to be specific. So if you remember how to do that, we just go through and say, okay, T's will pair with A's will pair with U, because RNA has uracil instead of thymine. C's will pair with G's, T's with A's, so on and so forth, all the way down the DNA strands. Like so. Then when you are done, I realize you probably can't draw a line if you're typing it in the Google Docs, but you can add some spaces between your codons, which again are the groups of 3 letters. And then, like I mentioned, you're going to need to use your genetic code chart, the other way, your genetic code chart, there we go, to write out the names of the amino acids that are represented by those codons. So I already did it here, so I wouldn't have to waste time looking them up. But if you look up AUG, that's the start codon. That makes sense. Methionine. So you'd write that down. Then the next one, ACA. If you look that one up on your codon chart, that's 309. GAG would be glutamic acid. So you write that one down. Next one, UGG, should be tryptophan. And then the last one, UAA, makes sense. That is a stop codon. So you're going to write those out. And again, that's going to represent our normal, original DNA strand and what it would look like, which amino acids would be brought together to create a protein if this DNA strand were not mutated. Then, if you read on in the directions, what I want you to do next is to take this DNA strand, and this time you're going to write it out again, but you're going to include a mutation. And this is where it can get kind of fun and kind of unique. You can add the mutation anywhere you'd like. You can change whatever letter you'd like, add whatever you like, take whatever letter out you would like. Except my request is that when you're asked to do an insertion and deletion one, you don't take out the letter at the end, the very last letter. You don't add a letter to the very end, because some of you will figure out that's like not very much work, and you're not going to see the result of mutation if you do that. But for example, the first one, I asked you to do a substitution mutation to your DNA strand. So I'm just randomly going to do this. I haven't planned it out yet, but if you had, keep our color coding going, your DNA strand, and I go, okay, now show me a substitution mutation. maybe I'm going to say, okay, here's the original DNA strand, TAC. I'll keep that the same. But then let's change this T to a G. Okay, so I've substituted this. I changed the T to a G. Uh-oh, that's a mutation. Then the rest would be the same. G, T, C, A, C, C, A, T, T. Okay? Then, after you write out your DNA strand with your mutation, and again, I did a substitution mutation. I changed a T to a G. Then you're going to need to do your mRNA strand. So I'm going to do A goes with T, A's go with U's, C's go with G's. Keep going all the way down the row. And then somehow maybe put extra spaces in your Google Doc. I'm going to just draw lines to separate them. And then, let's tip it down a little bit. You're going to need to write out the names of the amino acids. Well, AUG, that ended up being the same. So that's going to still be methionine, thionine. Now, this one is different. The unmutated, regular, normal strand was ACA. But because I substituted the T for G, the mRNA ended up being CCA. So if I go to my genetic code chart in my book, and I'm looking at it right now, CCA is proline. So now a proline amino acid is going to show up instead of the threonine. Uh-oh, that's the problem. That's the result of the mutation. Now, the rest of them are still the same three-letter combinations. So we can continue to write the same as last time. The mutation didn't affect them. But when the cell goes to put these amino acids together, we're going to have proline now instead of threonine, and that protein will look different and behave differently, and therefore we would have a mutation being played out in a cell. So again, the fun thing about this assignment is you get to pick which letter you want to change. For the next two that you're going to do, you're going to add a letter somewhere, and you're going to take a letter out somewhere. You can add a letter wherever you want, except for the very end, and you can take a letter out wherever you want, except for the very end. When you do that, at the very end, you're going to have leftovers. And by what I mean leftovers is you're going to have some letters that aren't going to be in sets of 3. And since they're not in sets of 3, you can't really look up and see which amino acid it is. So you just leave the letters at the end. You don't have to look up amino acid for it because it doesn't exist if it's only 2 letters or 1 letter or something like that. So because you can change whatever letter you want and take out whatever letter you want, insert whatever you want, everybody's may look different, which means the analysis and conclusion questions may have different answers for everyone. So like Luke Stenell's might look different than Luke Danzer's, or Kyle Blood's, yours probably will look different from Kyle Schulten's because of which letter you're choosing to create a mutation on. But ultimately, what I want you to gather from doing this is how badly did you mutate it based on what we should have gotten. Again, this is what we should have gotten, and then as you go through creating more mutations, you're going to see how far away from what we should have gotten did the amino acid sequence get based on the mutation that you caused. All right, as always, if you're still lost, call me during office hours on Google Meets, and I will be there to help you. Have a great time doing your mutations activity, and I will see you on the screen later.